purpose of today's lesson is to see what happens when we have a series of transformations that a figure undergoes. Now, what does a sequence or series of transformations mean? It simply is a transformation of a figure more than one time. Now, you might recall that we talked earlier in this unit about vectors. And first, before getting into the sequencing, what I want to do is to discuss or show you how vectors can be used for translations. A vector is a segment in the plane meaning the coordinate plane, 2 dimensions. Okay? One of its endpoints is a starting point, or the starting point, and the other, the end point. Okay, vectors have beginning and an end. The arrow shows you direction. Okay. Now, how does this work? All we're simply doing is taking the quadrilateral that we're going to graph here, and we're going to plot these 4 coordinates. There's A, there's B, there is C, and D. Okay. Now, you don't have it on your paper, but I'm going to tell you that we're going to translate this over the vector YZ. And YZ is located here. There is Y at the coordinate 2, -6, and Z is at the coordinate 5, -4. I have to tell you the vector, Y and Z. Okay? It's not something that you just figure out for yourself. You have to be told what the vector is. So I want to move by sliding the green figure. Now, what does the vector tell me? The vector tells me I'm going from Y to Z. How do I get there? Well, in the coordinate plane, we move horizontally and vertically. So I move 1, 2, 3 to the right, which is a +3, 2 up, which is a +2. So all I'm going to do is take all 4 points and move them 1, 2, 3 to the right, and 2 up. 1, 2, 3 to the right, 2 up. 1, 2, 3 to the right, 2 up, and same thing with D. So the vector has replaced the words move it 3 places to the right and 2 up, or the X +3, Y +2. Okay? Now, the question is, what if I then took the figure that's in red and moved it in the opposite direction from Z to Y? Where would I end up? And the answer is the same place as we started. It's like the undo button on a computer. Okay? All right. Now let's get to what we wanted to cover today. We want to do two transformations in the problem here. I first want to graph the original figure. I then want to reflect that, and then I want to translate the image. Okay? So we're going to draw our original figure. -9, 7 is A. -1, 7, B. -3, 2 is C. And then -7, 2 is D. Okay? So there's my original. Now, it tells me to first reflect it in the x-axis. So I'm going to flip it over from quadrant 2 to quadrant 3. And I'm going to do that by just counting how far away it is from the x-axis. Or I can see that my x-coordinates stay the same and the y-coordinates change their sign. Either way works. So there is new A prime and B prime. Please remember to use your primes. Then I want to translate it by using the rule x plus 5, y plus 3. So how does that go? 1, 2, 3, 4, 5. 1, 2, 3. There is D double prime. 1, 2, 3, 4, 5. 1, 2, 3. C double prime. For A, 1, 2, 3, 4, 5. 1, 2, 3. A is somewhere inside, or A double prime is somewhere inside. 1, 2, 3, 4, 5. 1, 2, 3. And there is B double prime. Okay? And then I'm done. So there's the first sequence of transformations. Now, we want to go to the next page, and we're going to do the same thing to this figure, except I'm going to go in the opposite order. All right? So let's graph our original. A, B, C, and D. Now, instead of the reflection coming first, the translation comes first. So I'm going to move everything 1, 2, 3, 4, 5, 1, 2, 3. That's new A. 1, 2, 3, 4, 5, 1, 2, 3. That's new B. 1, 2, 3, 4, 5, 1, 2, 3. That's new D. And 1, 2, 3, 4, 5, 1, 2, 3. There's new C. And I am there. That's our figure in blue. Now I'm going to take that and reflect it over the x-axis, which means my y values are going to change their sign, but my x values do not. D double prime, C double prime. And B and A double prime. Now, the question is, as you can see below, if you take the figure in red on this page and the other figure in red on the other page, the question is, are they in the same location? And hopefully you're right now saying, as I keep trying to move this, my orientation is off, hopefully you're saying to yourself, they are the same shape and size, which means they're congruent, because we just transform them, and we can prove that, but they are in a different location. And so, what is our conclusion? The conclusion is a sequence of a reflection followed by a translation is not the same as a translation followed by a reflection. So in other words, if I do the exact same two transformations but switch their order, if one was a translation and one was a reflection, I'm not going to end up in the same place. Now, let's do the similar series, but now using rotations. So I'm going to take my triangle, L, M, and N. I'm going to first plot their points. So -2, 2 for L, 3, 2 for M, 3, 0 for N. So the first rotation is 90 degrees clockwise about point L. So what that means is L is not going to move. I'm going to take the horizontal line LM and turn it one time like a clock so that it swings down to the left, to the right, okay? And it's going to end up 5 units below L, like so. All right? So all I did was take the black line and turn it one time. If you think of a compass, L to M is running east. If I go one time to the right, I'm now going to end up going south. All right? How do I find where N is? Well, N is 2 away from M. So I'm going to go 2 away over there. And there's my new figure. Okay? It's like almost like a pinwheel turning one time to the right. Okay? Now I'm going to take the blue image and rotate it 90 degrees counterclockwise about N, meaning N is not going to move. When I do this, I always want to be on the point that's the center of rotation, and a horizontal or vertical line to figure out. So I have the horizontal line NM. I'm going to pivot M one time to the left, meaning it's going to turn this way. That's the left. It's 2 away, so it's going to end up there. So there's my M double prime. How do I find L? Well, M to L is going to turn one time. So I'm at 1, 2, 3, 4, 5. It's M and L are 5 units away. And I am done. Okay? All right? Now, all I'm going to do on the next page is the exact same 2 rotations, but I'm going to change their order. So let's go to L, M, and N. L, M, N. Okay. Now I'm going to take that figure and I'm going to move it 90 degrees counterclockwise about N. So my line that's vertical, I'm going to turn to the left and it's going to become a horizontal line. M is 2 units away. And then M and L, 1, 2, 3, 4, 5, ends up like so. Okay? Then I'm going to take it 90 degrees clockwise about L. And I should have put L prime there. Okay? So L isn't going to move. It's going to go clockwise, meaning to the right. So I'm going to take this vertical line and move it one time clockwise to the right. 1, 2, 3, 4, 5. So it's going to end up over here. And then M and N. So that's the new M. N is 2 away. So I have my new figure that looks like so. Now, if you compare the 2 red figures, you will hopefully see that they are not in the same location. So what is our conclusion? They are the same size and shape. So that means they're congruent, but not in the same location. And so what that means is a series or sequence of rotations about a different, and let me just try to be a little bit neater with my writing, about a different point. Do not result in a figure that is in the same location. I'll write that down. Okay, so the point of today's lesson was to show you what happens when you have a series or sequence of transformations and when you may or may not end up in the same place. Both examples today were not in the same place. When you do your homework, hopefully you'll see one that does end up in the same place.